Chapter 20 is on acids and bases. So we're going to start with section 20.1, and it covers two different targets, 5.7a and then 5.7c and d. Let's start with acids. The definition of an acid is a substance that, when it's dissolved in water, produces hydrogen ions. So, produces hydrogen ions, H+, when dissolved in water. For target 5.7a, you have to be able to identify common acids. So one way is, if you're given the formula, you can look at the formula and you'll be able to determine that it's an acid. For example, something like hydrogen chloride, HCl. If you dissolve this in water, you're going to get H+ and Cl-. Therefore, this is an acid. So a general formula for an acid is HX, where X is an anion. So a negatively charged ion. It can be a little more complicated. You might have something like H3PO4. So there's your H's, and there's your anion. Your anion PO4 happens to have a 3- ion. That's why you need 3 H+ to balance that charge. So when you see a formula, it's pretty easy. Sometimes people think it's a little bit harder when you are looking for a name. There's a special way to name the ions, name the acids, sorry. So if we're looking at naming acids, and again, you just have to be able to recognize them. I'm not going to ask you to name this except for the 10th point. So, naming acids. If your anion ends in IDE, in the name, then you're going to have a special way to name your acids. Okay, so this is the first one. You will use a prefix of hydro, and you will use a suffix of ic and then acid. Okay, so on this one, HCl, this comes from hydrogen chloride. Okay, notice it ends in IDE. So what is the name of this acid? And I kind of left out the middle part. Okay, the middle part comes from the name of the anion. That's why we focus on the anion. So when I see HCl, I know it's going to be hydrochloric acid. Okay, so it's taking this name, putting the prefix in front, and putting the suffix on the end. So hydrochloric acid. Another example could be H2S. This is hydrogen sulfide. Okay. So this ends in IDE. So again, I need hydro and I need ic. So this would be hydro, and they call this one sulfuric acid. So it's just a little bit different. But again, you have to be able to recognize a name as something that is an acid. So if you hear hydrosulfuric, you can say, ooh, that's an acid. Okay. Number 2, the other one. If your anion name ends in 8. Let's go with that. So ends in 8. For example, H3PO4. This is hydrogen phosphate. Okay. Hydrogen phosphate. If it ends in 8, you're only going to have a suffix, and that suffix will be ic, and then acid. So we're going to use this name, and it becomes phosphoric acid. Okay. Or another one like H2SO4. This is hydrogen sulfate, So hydrogen sulfate would become sulfuric acid. Or maybe HNO3. Notice it doesn't seem to matter how many H's. The number of H's just balance our charge to make our compound neutral. This comes from hydrogen nitrate. So this is nitric acid. The third one is if your anion ends in -ite. Anion ends in -ite. Your suffix will be -ose and then acid. For example, so maybe having HNO3, maybe you have HNO2. Hydrogen nitrite. That would become, whoops, gotta spell it right, nitrous acid. Okay. So you just have to be able to recognize names. Formulas, again, are easy. If you look, they're all starting with H's. There's only one that you might see that might not start with an H. And we did learn it starting with an H. But they like to write it CH3COOH. This is acetic acid, okay, also known as ethanoic acid. Could have either name. Now the reason acetic acid comes up is we learned it as this, HC2H3O2, which is hydrogen acetate. Notice, ends in -ate, therefore it becomes -ic, acetic. So it still follows the rules. All right, so what else do you need to know about acids? You should know the properties of acids. So let's say you don't have a name or a formula to look at and you're trying to figure out if it's an acid. So the properties of acids. Now, if you're in a lab, don't taste it. However, if it's in your home and you taste a substance and it has a sour taste, like lemons, limes, grapefruits, it's acidic. So tastes sour. Okay, tastes sour. Again, if you're in a lab and you're trying to find an unknown, please do not taste it. Okay. It does, but it conducts electricity. They call this, here, I'll just write conducts electricity. Conducts electricity. They call that an electrolyte. Okay, it's an electrolyte. And it turns indicators, acid-base indicators, different colors. More specifically, it will turn litmus, that's an indicator, it will turn litmus pink. Okay, litmus will be pink. Another property, or another common indicator, is what we call phenolphthalein. Phenolphthalein. Stays colorless. Those are our two most common indicators that we like to use, and they're going to stay colorless. What other properties do we need? Oh, it will react with metals to produce hydrogen gas. So it'll bubble right up with a metal, and H2 gas will come off. All right, next we need to talk about, well, one other thing real quick. pH. We're going to use pH. Usually you'll use a pH meter, and it will tell you what the pH is when you put it in a solution, and then you'll know whether or not it's an acid. So if the pH is less than 7, it's an acid. Now, this is not a property, so keep that separate from that, but that's another way that we can identify it, is to measure its pH. Right. Next, bases. The most common definition for a base is it produces hydroxide ions. When dissolved in water. It's not the only one. So there are some others that you're just going to have to be able to recognize. So most of them will be like this. All your hydroxides are very strong bases. You'll have something like NaOH, and it's called sodium hydroxide, hence the hydroxide ion. You might have CaOH2, calcium hydroxide. So these are very easy to recognize when we're talking about our most common bases. The ones that are a little more difficult, NH3, ammonia. Notice it does not have an OH, however it is a base. Another one is sodium carbonate. When you see carbonates, those are bases as well. This is a very common base that we see. Properties of bases. It has some things in common. It will change the color of indicators, just like an acid, just differently. Your litmus turns blue, and your phenolphthalein turns pink instead of pink colorless. Okay. It's also an electrolyte. So remember, it conducts electricity. It does not react with metals, but if you get it on your fingers, it feels slippery. Although, again, not a test that you would want to do in a lab because it is corrosive. Okay, it is corrosive. So those are our properties of our bases. pH of a base is greater than 7. If pH equals 7, it's neutral. It's not either one. So keep that in mind. Now, another thing that's really neat, if you react an acid with the base, you'll produce salt and water. And we'll talk about that later. But they do react with one another and usually produce something that is neutral. Okay. So that's called a neutralization reaction. Sometimes they'll list that as a property, that an acid can react with a base and a base can react with an acid. So if you have an acid spill, a lot of times we like to use a base.